Okay, so welcome back. We will be looking at in this module, we will be focusing on the concept of this life cycle analysis. So, when I say life cycle analysis, this is essentially to find out the environmental footprint. As I said in the beginning of the previous video, that in the beginning of this week, that there is a parallel course going on LCA, that's actually a whole 8-week course. So, we are not going to cover that much detail here. We will just cover that how LCA, what is the basics and how it has been used in electronic industry, and what does that really mean in terms of the future of electronic industry, and also the future of what kind of e-waste will be generated. So, that is because it is all related based on, because the waste is generated from the discarded product. So, if the product design changes, the waste will also change. So, let us look at that. So, we will be talking about the LCA and the sustainable engineering concepts, especially from an angle of electrical and electronics industry. So, that is kind of the focus of this particular module. So, in terms of what does it mean to be green. So, many times we say it is a green, but what we really mean by a green, that's we'll try to talk about that. When we say green, what does that mean? What is the meaning of this green? What is sustainability? What do we mean by sustainability? So, green as essentially, many times when we talk about green, it's trying to be environmental friendly. That's what the green is, trying to be environmental friendly, where you can come up with a process which has less environmental footprint, with a process which is better for the environment. But these are all qualitative numbers. When we say green or better for the environment, so like okay, but how to quantify that? How to know the number that this is really better and that this process A is better than process B. So, those we will try to see how this environmental footprint could be quantified, and then this all get into the big picture in terms of the sustainability, which people talk about all the time, in terms of what is sustainable, what is not sustainable, and those we will be looking at that aspect. Just a second. So, sustainability, many times you hear the terms, when you look at the sustainability, you hear the term that environmental friendly, sustainable product, green product, and those are all different terminology used. And there is also stuff on biodegradable, recyclable, ozone friendly, eco design, and then there is the concept of greenwashing as well. There is a lot of greenwashing going on. Greenwashing means people present something to be green, but they are actually not green. So, it is presented as if it is environmental friendly, but when you do LCA exercise, when you try to kind of environmental footprint, you find that it is actually not that much of environmental friendly as it is projected to be. So, that is called greenwashing, and it is also happening with many products and processes. So, why all this concept is started, which again I explained it very in detail in my other class, but here in very simple way I will say that there is a lot of demand for resources, and that demand for resources led to this concept of this sustainable development, because the population is going up, the world population is going up, the power of purchase power is also going up in the population. So, there is a concept that we should have a sustainable development. Now, what is a sustainable development? That has been defined. If you can see over here, the development that meets the present without compromising the ability of the future generation. So, that is what the sustainable development that meets the need of the present. So, without compromising the ability of the future generation to meet their own needs. So, that is what we talk about when we say it's a sustainable development. So, within that framework of sustainable development, we have the concept of these like life cycle and other things have started. So, and then it all goes back to what can really the Mother Earth can handle, because there is a certain things that is, even the elements which are in abundance, they also have a certain X number of quantity. So, if we keep on using them the way we are using it, we will run out of that unless we start recycling, replenishing and all that. So, keeping those things in mind, what is the Earth's maximum handling capacity? How much things that the Mother Earth can really handle? So, there is an estimate of his population is around 13.4 billion. That is what people say, that estimate, that is the maximum population it can sustain. And looking at the population statistics, where we are headed, if you look at the annual growth in terms of in last decade, almost 10 years back. So, world was 6.7 billion and the annual growth 1.24%, lower developing country and the middle developing country, and then example is given with the US. So, US is 1.03, middle income, middle developing country, or they have 0.36, and low developing country is 1.41. So, Asia, Africa, they are actually growing at a higher rate than rest of the world. World is growing at the rate of around 1.24%. That was almost 10 years back. And if you look at, if you compare that with the per capita power generation, in US you have around 12 kilowatt per person, where industrialized in the developing country it is 1 kilowatt per person, and the other numbers is kind of in the middle. So, there is a if everybody, and then in the developing country there is a kind of, I would say, people have that trying to follow the so called American way of living. That is many times people think that is the best way of living, although now the Americans are thinking that the Eastern way of living is actually better than the Western way of living in certain parts. So, again, certain things is good in East, certain things in good in West. What we should do is try to take best of the both world rather than taking the worst of the both world, which many times we do. That is why many people, when they say that, oh, the Western civilization is harming Indian kids, and but like what about the Western, we are getting influenced by the Western culture. Yeah, but you can choose, you can put some filter in between and choose the culture, the practices of that culture which are actually good, like maintaining time, being ethically correct most of the time. Forget about the politician, but in most of the time they are, in general, people are ethically correct, maintains the office time, government offices, the way, the work ethic. Take those from the Western world, because they don't take our caste system and then our dowry system and other things. They don't take those from us, which are our bad things. They take yoga, they take those kind of good habits, even joint family culture. So, that is coming in some of the Western countries as well. So, take the best and then use that to your advantage. Don't take the worst stuff. So, it's you are given a platter. You can choose the different cultural components from there. If you are getting influenced by the Western world, choose the best one. Similarly, for the Westerners, when they look at the Eastern world, they can choose the best one, and the world will be a much better place. So, and these population that we will be coming, the future population can enjoy the world much better than what we are enjoying today. So, but why we got to that discussion is over here, when we look at this average per capita energy generation, US 12 kilowatt, US you have 12 kilowatt per person. So, if the entire world starts following that US lifestyle, then we will have lots of energy requirement, and energy requirement means a lot of coal require, whatever fuel you use, coal, nuclear, different fossil fuel, renewable energy. Even for renewable energy, you need to set up infrastructure. That solar power, the solar panels uses a lot of metals and elements from the periodic table as well, and those things needs to be mined too. So, when we think about that, oh, solar is great, yes, it is great, but that also comes with an environmental price. We need to see that whether we are paying enough, we should pay less environmental price than what we were paying with the coal based thermal power plant, and that is what it should be, but we need to quantify that too, and those things we can quantify using this particular tool. So, which will be looking at in this particular, we are trying to look at in this particular module. So, being green is trendy. What does the science say? Industry is looking for the ways to make it green. There are people out there who wants to be more greener, but how can we say that something is green? So, what is the currently happening to achieve this goal? For that to do that, as a scientist, we try to do what is known as the life cycle assessment. We try to perform a life cycle assessment, which is LCA, which we will talk about that. So, here you can see a sketch has been provided to you, and if you can look at it carefully, and it starts from, say, your supplier, where you get the raw material. This kind of shows you the raw material. So, raw material coming from there, then it is transported, then it comes to the manufacturing. So, your manufacturing is done, then the packaging, and then you use it, and then after use you dispose it. So, that is what is known as the cradle to grave, the life cycle. So, you started from the beginning, from the raw material, and you can follow this orange, the first line from the top. It goes to transport, package, manufacturing, again transport in between, packaging, again transport, then use, and then finally disposed as a waste product, either liquid waste or solid waste. So, that is your concept of cradle to grave, where from the very beginning to the very end. There is another, if you look at there was, if you can erase this part, and then if you look at the blue line, which kind of starts from the raw material, then goes to the transport, and then it ends after manufacturing when it reaches the packaging. So, that is what is a typical factory. When they are making any product, they have supplier, transport, manufacture, and they send it for they do the packaging, and then the thing is out of their gate. So, that concept is known as cradle to gate, as you can see over here. So, the blue one is your cradle to gate. So, as soon as it leaves the gate of the plant, this we stop there. The other is cradle to grave, which we kind of look at the entire life cycle from the very beginning to the very end. So, these are the two different concepts, cradle to gate and cradle to grave, which is important. So, whenever you look at a LCA report, you need to be careful whether it is a cradle to gate LCA or cradle to grave LCA. Some stuff is actually more harmful. As you can see, cradle to gate has 4 stages. If you look at that, it has 4 stages, where cradle to grave has 6 stages. Now, if something has bigger environmental footprint in the last 2 stage, and they are pretty good up to 4th stage, like first 4. So, it may good cradle to gate LCA may look very good in terms of the environmental footprint, but when you go to cradle to grave LCA, it does not look that good, even it may look much worse, because the impact is much higher during the use and the disposal, during the water, the wastewater that is produced during the use, or the electricity consumption is very high, or for whatever reason it has a irritation in the skin, and the disposal when it comes out in the environment, what kind of impact it has. So, based on sometimes you need to be really careful, like what LCA report you are looking at, whether it is a cradle to gate LCA or cradle to grave LCA. So, we will talk about that in this as well, when and we also talk about that functional unit and all that system boundary. So, life cycle assessment is essentially a scientific way to look at something going green. So, it is a scientific way to find out if things are really going green. It's whether we are just doing the problem sifting. One example I would like to give you, that I am not saying like one thing that we should evaluate, and some of you who are out there trying to look for a master's project or even for a PhD project right now, if somebody would like to do PhD on the topic, you are more than welcome. I can use this platform to do some marketing as well. But anyway, coming back to this course, say if you have following the news, Government of India is trying to promote electrical vehicle, and that electrical vehicle will be used by 2030. As per the present government announcement, we will be having pretty much all vehicle will be electric vehicle. Whether we get there or not get there, that is a different question, but that policy framework as of today goal is to get to electrical vehicle by 2030. If that is what my understanding was. If I am wrong, correct me on that. You can discuss in forum is where you can raise those questions as well. We will be happy to debate and answer. So, if you go to 2030, and then we also have some renewable energy goal. We also have how much renewable energy we will have, whether we are working on fossil fuel or like a renewable energy, non-renewable versus renewable, coal, thermal power plant, solar panel. So, we would need, what I am saying, why I am saying all that is presently that majority of cars are running on petrol and diesel. Now, if all the cars will run on electric vehicle, we have to produce lots of batteries at the first place, which will go into those electrical vehicle. The batteries requires a lot of heavy metals and other stuff which needs to be mined anywhere in the world, but it does not matter wherever. because LCA is a global, we are looking at the global impact. World nowadays is a global village. A pollution at any part of the world impacts the people in other parts as well. So we cannot just say that, oh, it's too far. It's happening in Kerala, I am sitting in Kharagpur or West Bengal, I am fine, I don't have to really worry about it. Sorry, you will have to worry about that, because the things are pretty much global these days. So in terms of, I was just talking about one country, but there are even the impact from other countries does travel. So looking at that aspect in terms of the electric car by 2030, we have to make all these batteries. The batteries will require a lot of heavy metals and other stuff. So there is an environmental footprint associated with that. So that's we should try to quantify. And at the same time, we have to look at what kind of energy we will use to recharge these batteries, because the batteries have to be recharged. So how to recharge those batteries? What will those aspects associated with that? What kind of energy will go there? Whether it will still be majority coal-based thermal power plant. Coal-based thermal power plant is known to have higher environmental footprint, higher emissions and other stuff. What kind of coal technology that will be used? And so it's just moving from the gasoline car to electric car. It may not really solve the environmental problem. It may, and but I'm not saying that it will not, but I'm saying we need to quantify the numbers to see what is the real benefit we are going to get out of that. Are we getting the benefit? And what is that benefit? Is that benefit worth the effort that we have to put? I hope it will be. And as an environmental engineer, I'm happy that we are going for electric car. But we need to look at the other aspect needs to develop along it as well. So the renewable, we need to get into renewable energy, which can support this electric car. The type of material that will go to make those batteries has to be environmental friendly material, so that they have lesser environmental footprint. All those things needs to be quantified. Then only we'll see the real environmental benefit. Otherwise, what we have seen in some places, that it just becomes like a problem sifting. Now, what is that concept of problem sifting? We'll get to that in this module, I think. But just to give you a problem sifting, is there was a problem in the auto, like right now, why we are talking about this electric car. The reason one being is that vehicular pollution that is happening on the road. Vehicular pollution is great, but what about the diesel gensets on the mall? Most of the malls they are running on diesel gensets. It's still many times we don't have the surety of power in many places, even in big cities, where some of the exams, like when we conduct certain exams using this computer-based exam, we were forced to run the center, the entire center running on DG sets, on generator, and producing a lot of air pollution issues, just because we cannot take the risk of even a 5-minute power cut, because if there is a power cut, there will be a lot of hues and cries. The students are taking the exam, and then of course unfortunately the friends in media become so hyperactive on many of these negative things. They don't, unfortunately, that's the really bad part. I'm a big fan of media people, but they try to show the negative stuff too much and the positive stuff too little. There are a lot of positives happening in the country as well that should be highlighted. Negatives, of course, you have to put that into public domain, but don't make it, don't sensationalize things. That's where the problem comes in terms of. So that's why we are even having lots of SUVs running on this diesel. Why? How come these SUVs are allowed to run on a diesel? So, and then in their own country, like for example, Innova, Toyota doesn't have a diesel driven car in Japan. So how come it has a diesel driven car in India? So how it was allowed in the first place to have that car? It's a luxury car. People should pay for petrol. Why they should take the advantage of that subsidy that is given for the diesel? So, but there are a lot of other issues. And then if we go for this electric vehicle, and there is say substantial less demand for gasoline, what will happen to all these petrochemicals, refinery companies, the jobs there? So all these things have to be looked into. So then only we can make a decision. So of course, going towards electric seems to be a positive step, but there are a lot of things that has to go into detailed calculation to make it. Is it really how much positive a step it is? At the end of the day, do we find that maybe it's only 5% or 10%? Does it really worth all this effort? Maybe, but we need to find that out, and that LCA will be a very good tool to do that. And it's not all, it's so somebody, again, so say if somebody is looking for a PhD topic, that's a pretty good, interesting PhD topic, where you have environmental engineering, environmental policy, all kind of merged together in terms of trying to and then you do it with the real numbers. And it will be challenging, but this will be really cool if somebody does that. And of course, if you need any help with that, you can always contact me. So, so in terms of coming back to what is the life cycle analysis, it's a compilation and evaluation of input and output. So it's a environmental accounting exercise. It's a compilation and evaluation of input, output, and the potential environmental impact of a product system through its life cycle. So you go from cradle to grave. So essentially what you're doing is an environmental profile of the system. You're making an environmental profile of the system. So anything that we do, we are using a tool, we are using a method. So as you have done your water wastewater lab at some point of time, I was assuming that most of you are environmental, or somehow you have done some chemistry lab for sure, or some you have done some testing. So every testing has certain method. So because to make sure that people say in India we are doing this test, the same test being done in other places, within India also at different places, we can compare our values together. So there is a standard method for doing certain things. So similarly for LCA, there is a standard method, there is an ISO method, like an international organization. This is what is used. So this is the ISO method, with that LCA is completed in a certain way, so that throughout the world people is doing it in a certain way. So we can do LCA on different stuff. What can be done with LCA? We can use it for product or project development and improvement to make it more greener. Strategy planning, public policy, like that that electric vehicle that I said, that LCA should be done to really see what is the benefit, and to also modify that policy if we need to make it a little bit different, to have better return in terms of the environmental footprint, because that's ultimately our goal is, isn't it? The whole exercise of that is to have the less environmental burden, and so that we have less environmental and human health issues associated with that. And the things can also be used for marketing and eco declarations to make it like how, whether it's a green or not green, how much green. People nowadays, there are some people out there in the market who wants to buy green product, but if you can quantify and tell them the numbers, so like how much green it is, they are always happy with that. So in terms of the product life cycle, how it is done, you start from the raw material acquisition. Let's see, you start with the raw material acquisition, that's the first one, that's basically from the mines. Then you have to do the material processing, manufacture, assembly, use and service, retirement, recovery, then you finally have treatment and disposal. So those are the steps. Raw material, first you do raw material, material processing, manufacture, assembly, use, service, retirement, recovery, and then you have treatment and disposal. So those are your steps. Now in between, for each one of them you see M and E here. Now what is this M and E? This M and E is for material and energy, material, energy input, and then you also see W at the bottom, and your W is the waste that is coming out. It's a solid waste, liquid waste, air waste, whatever, the waste which is coming out of the system. Similarly, M and E here, W, M and E, and then for each one of them you will have those. So you see that coming up. Then out of the whole process, you can have some which can be reused within the system. So you have some reused material, you can have some remanufactured material, you can have some closed loop recycle, things being recycled within the plant boundary, and then it could be some open loop recycle as well. So those are also possibilities. There could be another possibility. These are just an example here. So M and E is the material energy input process for the distribution, though that's your M and E. W is the waste, gas, liquid or solid, output from product process and distribution. And this is the material flow. How the material is flowing is that this arrow is showing you the material flow from the raw material acquisition to the material processing to the manufacture, assembly, use and service, retirement, recovery, and then finally treatment and disposal. So this is how this whole product life cycle stuff is done. So what we try to do here is we try to do an environmental accounting exercise. So we try to calculate all the inputs going into the system and also all the output coming out of the system in terms of emissions. Then we take the emissions data and try to quantify that in terms of the environmental impact. So that's what we'll see. So to do that goal, To do the LCA, for what we try to look at the what is the makeup of the LCA, how the in terms of its goal, what is the goal, what is the purpose of doing the LCA, what is the who is the audience, who will use this data. Then we have to, once we know what is the goal and scope, we have to do what is known as the inventory analysis. So, after you have this goal and scope things worked out, after you have this goal and scope things worked out, the next is what we try to do is inventory analysis. Inventory analysis, this is the most time consuming part of any LCA exercise. So, what is the function and functional unit? What is the function? Function is for any particular product, what we are trying to, I'll show you some example and it will make you clear. Function is essentially what a product, what is it, what it will do, what is the intended function. For example, if you're for a pen, the function is to write. For a pencil, the function is to write, isn't it? That's the function. The functional unit for a pen or a pencil could be writing of 1 page, or writing of 10 page, or writing of 100 page. So, those in a with a similar margin and other stuff. So, that becomes your functional unit. So, at what unit you are trying to compare. So, function, the two products or process that are being compared should have similar function. That's why then it will be a proper comparison, and then you have to choose a functional unit on the basis of which you will be compared. So, we will see some example will make you clear, and then we have to come up with some boundaries, and then what kind of data will be required, what assumption needs to be made, are there any limitations. So, we will talk about those when we do some LCI. I'll show you a detailed example. Then we have an impact assessment. What are the environmental, social and environmental effect? That is what we try to find out from the emissions that is coming in. What are the environmental impact? What are the social and economical impact? But in terms of LCA that we will be talking about, we are mostly talking about environmental. For social and economic, we do not do that as part of regular LCA, what is called the cost. One is called LCCA, which is a life cycle costing assessment. The other one is the social LCA. There are guidelines for that is also coming out. So, once we do this assessment, then ultimately what we are trying to do is ways to reduce environmental impact. That is the goal, how to reduce the environmental impact, what conclusions can you draw, what recommendations can be made. So, this is how this LCA exercise is done in terms of when you try to go for making an try to calculate the environmental footprint and its application for product improvement of environmental performance. So, let us look at one example, and then we will be closing this video. So, if you think about it, let's see what is that. Okay. So, let's look at this example, and then we'll close this particular video. So, LCA in action. So, think about that paper plate versus China plate. So, if you have to compare these two categories, the paper plate, which is the use and throw paper plate, China plate is the plate which you have to clean it and use it again. Now, if you have to compare these, can you compare one paper plate versus one China plate? Is it a fair comparison? Is it okay to compare two? The answer is no, because we know that if we do one-to-one comparison, one paper plate versus one China plate, of course, the paper plate will win in terms of the environmental footprint, because it will take less amount of energy, less amount of material to produce it, and then it will be disposed. It is a paper plate. Even if it goes to the landfill, it will have certain emissions. But if you look at the China plate actually will have even its manufacturing requires much more power, much more energy, and much more energy, much more material, and that could be used. So, what we do in terms of these kind of stuff is we try to actually give them equal footing. So, there should be fair comparison. So, first thing we talk about is, okay, what is the function? There are these two products, but what is the function of these products? So, function of all, whether you use this plate or the other plate, is to provide a meal. So, that is your function. Now, what is the functional unit? So, how much meal? So, we can choose, say, that is up to us. We can say 100 meal serving. 100 meal serving using method A versus method B. Method A is paper plate, method B is China plate. So, now we are at equal fitting. We are serving 100 meals using either paper plate or China plate. Now, when you are serving 100 meals, you need 100 paper plate. Sometimes those of you who stay in a hostel, you can probably use less. doesn't have to clean those paper plate. Sometimes it's chalta hai, but you cannot do that. So as per our problem, we'll assume that you are using a fresh paper plate for every meal. So you use 100 paper plate. For the china plate, you have to clean it. You will do the cleaning, isn't it? So you have to do the cleaning of this china plate. So you have to clean it 99 times to use it. First time you used it, then you cleaned it another 99 times. So there is a cleaning, the dishwasher, a use of dishwasher for 99 times, and all those things we have to find out. Then now what material and resource are used to make it? We need those kind of information, what goes into making these material, and how it was produced, what was the process stuff. Then we look at the material input, energy input, and the emissions that is coming out through the whole process. Then we try to quantify what is the impact to the. So we try to quantify in terms of the impact to the environment during the production. Is there waste? What is the waste? Washing of the china plate will produce some waste. Then the type of data we require, we can have a data inventory. How do you know which one is better? Then we have to compare. We have to do the looking at the like all these inventory data. We can try to quantify, and in terms of the carbon dioxide equivalent of these two processes, whichever is less will be better. So that is done, and how it is done I'll show you like in the next video. So this is how typically LCA is thought about. So we just kind of started this LCA. In the next video we'll try to finish it. So this is in terms of LCA in action. So you think about this in this video. Before you go to the next video, think about if you have, I will give you another example. If you have to do paper pencil versus mechanical pencil, or if you have to do a e-reader, which is you are reading the book on a Amazon Kindle or an iPad, versus iPad becomes more complicated. We'll talk about that in the next video. So but just think about this: Amazon Kindle versus a physical book, how you compare them if you have to do environmental footprint. Paper pen, like a mechanical pencil versus your what you call regular pencil, those HB, Nataraj HB, Camelin, those regular pencil versus the mechanical pencil, which has those lead in the middle and then has some spring and other stuff. So if you have to compare, how will you do that? Or there could be other things too, like which can come to your mind. So we'll continue this discussion in the next video, but think about those questions before you listen to the next video, because I'll give you answer there. So thank you, and again I'll see you in the next video.